Very big welcome to the European Spaceport in French Guiana and our live broadcast Road to Space. On the pad we have Europe's new heavy lift rocket Ariane 6 getting ready to take to the skies for its third launch, and on board is our passenger METOP second generation A1, the first in a new series of European weather satellites which will also improve our predictions of extreme events like storms and better understand climate change. It carries 6 instruments on one satellite, including Sentinel-5, to analyse our atmosphere as part of Europe's Copernicus Earth Observation Programme. Now, we are about 16 kilometres from that pad, overlooking the Mission Control Centre. Indeed, that's actually our view from the commentary box. I'm Katie Haswell, and joining me is Vincent Baudel, who is our rocket expert from Arianespace. It's great to have you with us, Vincent.
Yes, hello, Katie, and hello to everyone. So great and exciting to be here tonight in Jupiter for this new YouTube Live.
Now, Vincent and I are going to be with you right through until separation of our satellite, and that's going to be happening in about an hour and a half's time. But we have lots for you between now and then. We'll be discovering our satellite and its 6 missions on board. We'll be finding out about operations across the range, and we'll also be meeting the teams, starting here in Mission Control. We call it the Jupiter Control Centre. There it is on the right-hand side of the screen. Very much the nerve centre of operations. The teams in here inside what we call the fishbowl. It's the glass protecting them and making all the final decisions in there as well.
Yes, and there will be as well the Ariane 6 launch site. That is a dedicated area designed for launcher final preparation. So it includes, of course, the launch pad, but also the launcher assembly and the integration building.
We'll also be meeting the teams in the Launch Control Centre, or CDL as it's known here at the base, closer to the pad. These are the teams who are responsible for all the operations on the rocket and the pad, right up until liftoff. Laser focus concentration in there now.
Yes, and we will discover as well the quick look telemetry team. So this team collects real-time data that the launcher sends, which allows us to continuously analyze the launcher behavior and confirm that it is as expected.
Indeed. Now, let's find out how things are looking for the launch, and who better to tell us than the CEO of Arianespace, David Cavaioles. David, how are operations progressing?
Well, so tonight we are going to operate Ariane 6, which is a brand new heavy launcher of Europe. So Ariane 6 is now on its launch pad. All the indicators are green, the meteo is okay, and we should be able now to perform the launch in a little bit more than 20 minutes.
Great, that's good to hear. David, tell us a little bit more about our passenger.
For sure. So today our client is EUMETSAT, so the European institution in charge of meteorological satellite. And for EUMETSAT, we launched a very special satellite called METOP-SG A1. So this is the first of a new generation of polar orbiting weather satellite. And within this satellite, we have 6 instruments, 6 very innovative instruments. And it's worth noting that one of them is called Sentinel-5, and it's part of the well-known Copernicus program of the European Commission.
Indeed, so a very important satellite, not just for Earth observation, not just for our planet, but for literally for each and every one of us on Earth.
Yeah, absolutely, because this satellite will provide extremely valuable data to increase the accuracy of weather forecasts, but also to allow scientists to better understand climate change, to fight against pollution. So this is really a satellite that will provide a tangible outcome for all the European citizens, and for this reason, at Arianespace, we are extremely proud to proceed to this launch tonight.
Absolutely. Well, David, thank you very much indeed for keeping us up to date there. David Cavaioles, thank you. Right now, just a little reminder, if you happen to be watching us on YouTube, don't forget you can click on the bell to subscribe and follow our launches. I highly recommend that you do. It's always nice to see what's going on, and we do have an awful lot going on here at the spaceport. 21 minutes and 47 seconds to launch our rocket on the pad there. As David said, we are all green and go for launch. Our satellite's due to lift off in 21 minutes and 33 seconds. What's going to happen after that?
Yes, so tonight the Ariane 6 launch vehicle will lift off toward the north, powered by its main cryogenic engine and its two solid propellant booster. So this will be separated 2 minutes and 15 seconds after launch, followed 1 minute and 17 seconds later by the fairing separation once the launcher has left the Earth's atmosphere. The launcher will continue its ascent up to 7 minutes and 35 seconds when the main stage will have finished its job. So the onboard computer will command the shutdown of the Vulcan engine and the main stage will be separated. A few seconds later, the Vinci upper stage engine will be ignited for the first time and will burn for about 12 minutes, putting the launcher into an intermediate orbit. We will then have a long coasting phase going up around the North Pole and down Eastern Asia until shortly before the hour, when the upper stage will be reignited close to Australia. This second boost, which will last only 47 seconds, will allow to reach the targeted orbit. Then, therefore, METOP-SG A1 will be separated. And after that, the upper stage will enter a new coasting phase before a third boost, which will slow it down, followed by stage passivation and leading to a re-entry above the Indian Ocean. And this deorbitation will avoid, of course, leaving any debris in orbit, any debris in space.
Very, very important, of course, to avoid space debris. And once METOP-SG A1 is released, it's going to start the process of testing and calibrating before it can start its job. That'll be in about a year's time. And my goodness, what an important job it has. With people across the world coping with increasingly extreme weather events, there's never been a better time to improve the accuracy of our weather forecasts and our climate predictions. And that's exactly what our satellite's going to be doing.
Yes, Europe's weather service, EUMETSAT, is launching its new series of polar orbiting satellites, so the second generation of METOPs. It will consist of 6 satellites built by Airbus Defence and Space, working in pairs with an A-type and a B-type. And today we are launching the first one in the second generation, and it is an A-type. That's why it is called METOP-SG A1, that is to say, METOP second generation, A-type number 1.
And on board, it actually carries 6 instruments, I think 6 different but complementary missions. One of them is Sentinel-5, as David was telling us earlier, which is part of Europe's Copernicus program to monitor our planet. And it's very much our eye in the sky for air quality. And that's important because air pollution contributes to millions of premature deaths every year worldwide. So this is super important. Sentinel-5 is going to track pollutants, greenhouse gases and ozone levels across the entire planet. So let's find out a little bit more now about our satellite, METOP-SG A1. space technologies do play a huge role in enhancing our everyday here on Earth. But of course, we've got to get them into space, and that's our job today. And to do that, we need a spaceport. And our spaceport here at the European Spaceport it's a big place, isn't it, Vincent?
Yes, the European Spaceport is a very big place, so nearly 700 square meters. So corresponding to 6 times of the surface of inner Paris, to give you an idea.
Yeah, indeed. And we call the whole thing the range, which includes the tracking stations dotted along the flight path. And because everyone's spread out across the range, everyone's got to be looking at the same information. And that's why all eyes are focused at this point before launch on the status panels. You saw them back there in the Mission Control Center. We can see them back there throughout the spaceport. And right now the panels are all green. That's a good sign.
Yeah.
So tell us about the panels then.
Yeah,
Professor.
so the status panel shows the live go, no-go status across the base. So, as you said, all must be green for launch to go ahead. And they show us the health of 3 main systems across the base. So, of course, the launcher and its ground system. You can see Ensemble de lancement plus lanceur. There is as well the satellite, of course, METOP-SG A1. And a third group dedicated to the range, including the telemetry, the radars, the weather, and of course the safety.
And the teams watching over those are in the Launch Control Center. We met them earlier, CDL, as we call it. They deal with everything to do with the rocket and the launch zone. What are they doing right now?
Yes, so the Launch Control Center, so the CDL, is where the Arianespace and Ariane Group teams are getting the launch pad and the rocket ready for liftoff. So these are the operations team, and they're sending the various commands to turn the launcher avionics on, to fill the propellant tanks, to pressurize the tanks, and to do all the planned tests to confirm that the launcher is ready for launch. And behind them, behind the glass windows, the engineering teams are monitoring all these operations closely, making sure that all parameters are as expected. So they are following all physical parameters, temperature, pressure, electrical current, and so on. And these teams are working in tandem and in real time with the teams in the Space Code Control Room in Paris, who designed and built the rocket. So they are also monitoring the launch from across the ocean. And the teams communicate with each other constantly, and they monitor operations and take important decisions.
Indeed, and that's good. The more people on the job, the better. Right, now we had the pre-final weather check, if you like, at T-20, everything green there. We've got the final weather check coming up in 40 seconds at T-10. What kind of things do we have to look out for?
Yes, so first we need to monitor the high altitude winds, so between 10 and 20 kilometers. So we need to make sure the wind speed and direction are below a certain limit, not because the launcher could not withstand it, but for safety reason in case of launcher malfunction. And we need also to monitor the risk of lightning during the ascent to avoid being hit by lightning, which could harm the launcher avionic. We monitor storm clouds, and on the ground there is not such a problem because we have 4 lightning masts, as you can see on the screen. So 4 lightning masts to protect the launcher while sitting on the pad.
And we use a weather balloon, don't we?
Yeah. We use weather balloons carrying instruments that send back information on atmospheric temperature, pressure, and humidity. And we use as well sensors around the launch base and along the coast for the wind and for the lightning.
And the weather status panel is green, so that's good news. We go for launch. We've had some very clear skies in the last few days here, so fingers crossed for a very beautiful launch tonight. 9 minutes and 14 seconds to go. Here on the pad, we've got various things we can look at. You mentioned the lightning towers. Have a look at that great big building behind the rocket. It's called the gantry, and it's got various jobs, but the rocket is actually, it was protecting the rocket before the launch, and it's actually built on great big wheels, isn't it? gets rolled back just before launch.
Yes, so the gantry, the mobile gantry, so it is a very huge structure, so 8,200 tons of metallic structure, so it weighs about the same as the Eiffel Tower. So it's built on wheels, and it rolls back just before launch. It travels very slowly along a set of rails at 7 meters per minute. So 90 meters high and 40 meters large, and 120 meters rolled back.
Very big. Now, this was some weeks ago, the operations to prepare the
Yeah, so the cryogenic stages of the launcher arrived in French Guiana on the brand new cargo ship called Canopée, which is also powered by wind. So they were then transferred to the spaceport, and launcher operation started with the horizontal assembly of the main and upper stage in the launcher assembly building, followed by several verification and checks. Mid-July, the integrated core stage was transferred to the launch zone on an automated guidance vehicle, and once it arrived on the launch pad, it was vertically tilted, lifted up inside the mobile gantry, and accurately positioned on the launch table. And of course, the two boosters were then transported to the launch pad and of course integrated onto the main stage. After that, our passenger, METOP-SG A1, arrived in French Guiana in mid-June. The spacecraft container was transferred to the preparation facilities where it was unloaded in the clean room. Some inspection, checks, and health tests were run. Then the spacecraft was transferred to a special hazardous clean room where it was fueled. The combined ops started with the mating of the spacecraft on its fly adapter. The spacecraft stack was then transferred to the final assembly building where it was integrated on the Ariane 6 launch vehicle adapter. And after final cleaning and checks, the two half fairings were positioned around the spacecraft and finally assembled. The satellite and fairing stack was transferred to the launch zone by road, and once arrived on the launch pad, the composite was hoisted inside the mobile gantry and integrated on top of the launcher, an operation completed last Wednesday. And about 9 hours ago, the mobile gantry was rolled back.
Indeed, to reveal our rocket. And of course, rolling back the gantry marked the beginning of what we call the actual final countdown. There have been lots of operations, haven't there, in these last 9 hours or so? What are the highlights?
Yes, so after the gantry was removed, all the propellant lines were flushed to avoid any leftover humidity in preparation for the cooling of the lines, and then the start of fueling, which started around 6 hours before launch. In parallel, there have been electrical checks and harmings, getting the telemetry and radars ready. And now we are in stable situation, waiting for the start of the automatic synchronized sequence.
And that's coming up in the next 20 seconds. Our range operations manager getting ready to announce it. He's picked up the phone. So the synchronized sequence, the automatic sequence, is normally the last 5 minutes of a countdown. So far, we have not actually received yet a confirmation that that has been triggered. We're looking at green status panels. And we're hoping to hear soon from the range operations manager.
À tous de DDO, séquence finale lanceur passée à H0 moins 5 minutes.
Okay, so we have...
Has he announced the beginning of the synchronous?
Yeah.
He has indeed. Okay, so that's good news. The last 5 minutes of the of operations, and lots going on during this time. Lots of very, very detailed operations and very fast timed to the millisecond.
Yes, and all those operations are very precisely timed, combining system checks and pressurization of the cryo tanks, activation of different systems and valves. The control of the operation is gradually being transferred from the ground to the computer on the launcher, and it will be the launcher on board the computer who will actually send the main engine ignition command. The same computer will check the main engine before sending the fueling arms disconnection and booster ignition commands for liftoff. Since we have a fixed launch day today, launch today, without a launch window. If we have a stop for any reason, we will need to postpone the launch.
So we're looking here at our rocket on its pad. Just a couple of thoughts about the ignition sequence. We're going to switch the Vulcan engine on before we switch on the boosters.
Yes, 7 seconds before liftoff, the Vulcan engine is ignited. That allows to check it is running correctly, smoothly, before we ignite the boosters.
And let's just briefly tell people about the cryogenic arms, Vincent. You can't see them here, but actually once we get another shot of the rocket, there we've got a great view of them, those yellow arms.
Yes.
So they're clamping onto the top of the rocket, and they are feeding cryogenic fuel into the top of the rocket, very, very ultra cold.
Yes, so the cryogenic arms, so 13 meters long and 20 tons. Huge mechanical arms connected to the launcher to ensure the fueling of the upper stage, with liquid hydrogen and oxygen at extreme temperature going up to minus 250 degrees. And they also enable to maintain a constant pressure in the tanks and the stability of fluid inside the launcher up to the liftoff time.
And feeding the same cryogenic fuel into the bottom of the rocket. You can't see them at the moment, but if we change the shot, we might see the big tanks going in there.
Yes, we do the exact same thing on the main stage, so the lower stage. We have the MANG fuel connection, but this time with massive system called MANG installed on the table, so 10 meter high and 100 tons.
Getting close now to the 1 minute mark.
À tous aux DDO, attention pour moins d'une minute. Top à 0 moins 1 minute.
We are 1 minute to launch. Our very best wishes now to all the teams. Good luck, everyone. Bon voyage. Ariane 6 and METOP-SG A1 with Sentinel-5.
À tous de DDO, attention pour décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage de ZSR et décollage. La propulsion est nominale. Pilotage calme, paramètres à bord sont normaux. Propulsion nominale. Les paramètres à bord sont normaux, la trajectoire est nominale. La propulsion est nominale. Paramètres à bord sont normaux, passage ultrasonique.
On board the third Ariane 6 rocket, blazing a trail across the night skies here over the Guiana Space Center, the European spaceport in French Guiana. They have started their journey.
Pilotage calme et passage de la pression dynamique max.
We are hearing that the pressure is calm, everything is going well. And we are looking here at two boosters, Vincent. They're doing all the work right now, aren't they?
Yes, we can see the two boosters. So we are in the booster phase. So the mass of the launcher on the pad, 535 tons. So to lift off, you need more thrust than rate. So we need 900 tons of thrust, and the booster are providing nearly 90%
Début de booster ESR, paramètres à bord normaux.
He's telling us that everything is going
Pilotage
well.
calme.
Everything is normal. Getting close now to... We should see, actually, those boosters being jettisoned on our cameras. We'll see two dots kind of moving away from... We're looking there, I think, at probably the engine on the main stage. There we go. We can see the boosters.
Séparation ESR.
And we have confirmation, and that's what it looks like. The two boosters falling away there.
La propulsion est nominale.
Yeah.
So lucky we've got incredibly clear skies.
Image, yes.
Looking now at the main engine, the Vulcan engine, which is now
Trajectoire nominale.
and he's telling us that everything's normal. Right now, the next thing to be jettisoned will be the fairing. That's the top, the nose
Manœuvre en roulis en cours, tout est nominal.
Everything's fine, and the fairing is protecting our satellites. Actually, we've got a good view of it there on our CGI images, the top of the rocket, the cargo bay, if you like. Our
Les paramètres à bord sont normaux.
Stowed inside there, Vincent. It's got a number of jobs, hasn't it?
Pilotage calme.
Yeah, the fairing on top of the launcher has several jobs. So the first one, as you can imagine, is to protect the satellite on the ground from dust, humidity, and so on.
Trajectoire nominale.
And at launch, it is an acoustic protection against a huge vibration generated by the different ignitions.
It's very loud.
Yeah, and during the flight, so right now, it protects the satellites against air friction and the extreme heat as we travel through the dense part of the atmosphere. And now...
We have separation of the fairing. It's been jettisoned, so we don't need that anymore. We're out of the dense part of the atmosphere that you were describing. And look at that. Wow. We can see our satellite for the first time, and it's a big one. It's the gold structure.
Yes, so we can see the METOP-SG A1 spacecraft position on top of the launcher. So it is attached to the upper stage with a conical adapter. So METOP-SG A1, a big bird of more than 4 tons, positioned on top of the launcher in stowed configuration, of course, for the flight. So in gold color, we can see the multi-layer insulation that covers and protects the spacecraft sensitive elements from thermal radiation. And in gray and black, we can see other parts of the spacecraft like instrument or specific equipment.
Propulsion nominale.
Indeed, he's telling us everything's going well up there in space. And those instruments, we have 6 different instruments on board. Let's tell you about them. If we go clockwise from the top right, everything's going well. Yazi, next generation, giving us profiles of temperature and humidity, also giving us information about the gases in the atmosphere.
Yes, and just below, the RO, that is to say radio occultation sound. It listens to how the signals from navigation satellite like GPS and Galileo bend through the atmosphere to map temperature, humidity, and pressure.
And then below that, we've got MWS, the microwave sounder. Now that's able to see through clouds, giving us information about temperature and humidity, as well as snow and ice.
Yes, and on the other side, we have the 3MI, which is a new way of monitoring the tiny particles, the aerosol high in the atmosphere associated with the formation of clouds. And just above, Sentinel-5 that will gather data about our atmosphere and air quality as part of Europe's Copernicus Earth observation program.
Indeed. And
Trajectoire nominale.
Right at the top on the top left-hand side is MET-Image. It's a visual and infrared imager giving us high-resolution images which are very useful
Propulsion nominale.
for... He's telling us the propulsion is normal, very useful for looking at the clouds and the land surface. It's also useful for looking at sea ice and the surface of the oceans. So 6 incredibly
Il reste 1
important
minute de poussée Vulcain.
instruments all packed on board one satellite bristling with technology. And our satellite METOP-SG A1 is a great example of teamwork and European excellence.
Pilotage calme, propulsion nominale.
In observation from space, it was built by a consortium of different industries led by Airbus Defence and Space. Now, a quick word about
Les paramètres à bord sont normaux.
Top right-hand side of your screen, the green line is the planned trajectory, and the white cross is our actual position of our launcher. So, we are burning, Vincent, the main stage. It's that whopping great big tank of fuel in the middle of the rocket.
Yes, we are at the end of the main stage flight. So the main stage, 33 meter high, a mass of 23 tons, and fueled with 154 tons of cryogenic
Extinction
propellant.
Vulcain.
Yeah.
And he's just confirmed there that we've switched the main stage off.
Séparation LLPM.
And we have separated it and jettisoned it.
Premier allumage Vinci.
And we have ignition, our first
Tous
ignition.
les paramètres à bord sont normaux.
Vinci upper stage, and everything is going according to plan. So yes, now we've really gone into the next phase of our flight. The upper stage has taken the baton. Its job is
Orbite atteinte à extinction Vulcain nominale. Les paramètres à bord sont normaux.
Everything's going fine. Everything's going according to plan. Its job is to deliver its
Pilotage
passenger
calme.
to its required destination in space, where we can drop it off. And to do that, it's got the engine on it, which is the Vinci.
Yes, the
engine.
Vinci. So the upper stage is equipped with the Vinci engine. So
Les paramètres à bord sont normaux.
two ignition of the engine will be necessary.